All right, section 9.4, arithmetic series. We talked about sequences of numbers. Here's a sequence of numbers. If the sequence ends, it's called a finite sequence. If it continues with dot, 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 that is an infinite sequence. Okay? Now, let's just review really quick. How do you write the explicit formula? First of all, is this arithmetic or geometric? From 6 to 9, 9 to 12, 12 to 15, what are they doing? We have a common difference of 3. So how would you write an explicit formula? It's the first term plus n minus 1 times d. Well, the first term in the sequence is 6. And n is going to be like the term you're looking for, d is 3. So this equation, this rule, is 3n minus 3 plus 6, which is 3n plus 3. So if I wanted to find out, if I look at this sequence right here, dot, 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 if I wanted the 10th term, I'd put a 10 in here. Well, in today's section, what you're going to do is talk about what a series is. A series is a sum. You're adding up or subtracting. You're going to have these sequences, but you're going to have plus signs in between. So a finite series, a series is going to look like this. 6 plus 9 plus 12 plus 15 plus 18. This is called a finite series. They're asking you to add these up, and you can obviously take a calculator and add them up. An infinite series is 6 plus 9 plus 12 plus 15 plus 18 plus on, so etc. Infinite. Today our investigation is this finite series. We're going to add these up. Now obviously if I asked you to add these numbers up, you could take your calculator and add them up. But what if I would have had this pattern continuing and there were like 100 numbers? Are you going to sit there and add them up? No. There's a formula to sum these up. So today we're summing up finite arithmetic series. Now if I ask you can you point out the difference between a sequence and a series? What's the difference between a sequence and a series? What do sequences have that series do not have? Commas. So the way I remember it is the C in sequence represents commas. That's how I remembered it. So that might help you. You're going to have a question on your test. It's going to give you this, and it's going to say, is this infinite, finite, is it a sequence, is it a series, is it arithmetic, is it geometric? So you have to be able to tell, is it arithmetic, is it geometric, is it a series, or is it a sequence? Sequences have commas. Series have plus or minus signs in between them. Okay? So now, what is the formula for adding up a bunch of numbers in a series? Looks like this. The sum, S stands for sum, of n number of terms. In this case, we have 5 terms here. It is the number of terms you're adding together divided by 2 times the first term in the sequence plus the last term in the sequence. So if I wanted to add these up, all you do is count how many terms you're adding up. 1, 2, 3, 4, 5. You have 5 terms over 2. The first term is 6, and the last term is 18. Well, what is 6 plus 18? 24. 2 goes into 24 12 times, and 12 times 5 is 60. So if you take a calculator and add these up, the sum is 60. This is the formula. Well, what happens when you have a question like this next one right here? I'm giving you this series, and I'm asking you to add numbers 2 plus 4, plus 6, plus 8, plus 10, plus all the even integers to 100. So what is the sum of all the even integers from 2 to 100? Well, the formula looks like this. The number of terms over 2 times the first term plus the last term. Well, how many terms are you adding together? 2 to 100. We're not adding 100 terms. How many is going to be here? 50. There's 50 terms. In the first term is 2, and the last term is 100. So what is 2 plus 100? 50 over 2 is 25 times 102, and that sum is 2,550. You're going to want to use a calculator today.
How'd you get 50 again?
Because there's, if I say 2 through 100, but I'm only adding the even numbers, there's 50. How many numbers are there from 1 to 100?
100.
100, but I'm only adding every other one.
Okay.
So there's 50 of them. Okay, now check out this next example. Little different. There's a twist to this one. What is the sum of this finite series? But there's a problem. They don't tell you how many numbers you're adding together. And you're not going to sit here and count. I do know that in this formula, this is my formula, n over 2 times the first term plus the last term. I do know 4 is the first term, and I know 99 is the last term. So this is what I have so far. My problem is I don't know how many terms I'm adding together. So my job is to take a look at where 99 stands. 99 is what term? So can you review with me the formula, the explicit formula for this series? If it were a sequence, it'd be 4, 9. So 4, 9, 14, 19, and so forth. Can you tell me what the pattern is? What are they doing from 4 to 9? From 9 to 14, 14 to 19, what are they doing?
Adding 5.
They're adding 5. Whoops. So, in other words, a sub n is equal to the first term in the sequence plus n minus 1 times d. Well, the first term is 4, and we don't know what n is. We're going to figure this out, and d is 5. So I want to know what 99 is. 99 is what n value? What term is that? So let's solve for n. You have 99 equals 4 plus 5n minus 5. 99 equals 5n minus 1. Negative 5 and 4 is negative 1. Add 1, get 100, and divide by 5. That gives us a value of 20 for 99. So 99 is the 20th term. First term, second term, third term, fourth term, fifth term, 20th term. So what are you going to put here? How many terms are you adding together? 20 of them. So it's 20 over 2. What's 20 over 2? 10. What's 4 plus 99? 103. What's 10 times 103? 1,030. So if I added up all these numbers, you would get 1,030. Now, I have to show you, there is a way to write this problem in summation notation. This is the Greek letter. It means sum up. You're going to put right here the rule. Okay? That's the rule. Down here is the first number you're going to add in the sequence. You're adding the first term to which number? You're adding the 20th term. So here in this equation, you're going to have, to write this problem in summation notation, you're adding from term 1 to term 20. The rule is, what is the rule? Here it is right here. It is 5n minus 5 plus 4, which is 5n minus 1. So you have here n equals 1 to 20, 5n minus 1. That's how you're going to write it in summation notation. So let's take a look at another example. We're going to do a story problem at the end. Look at problem, I'm on problem 3. Everyone skip to problem 3. Multiple choice. Cover your multiple choice answers. I want to go through this with you. How do you write the summation notation for this series? We've got 7, 11, 15, ... 203, 207. I need to figure out how many terms we're adding together. So we're going to add from the first term. I don't know what this is. I don't know what 207 is. What term is that? Is it the 20th term? Is it the 50th term? What is it? We're going to figure that out in a second. And I also do not know what the rule is. So there's two things I need to find. I need to find what place 207 is and what is the rule of this problem. So the rule we can find out. We did that in section 9.2. How do you do the rule? Looks like this. It's the first term plus n minus 1 times d. Well, the first term in the sequence is 7. Actually, this is a series. And d is going to be 4. We're adding 4. So in other words, 7 plus 4n minus 4, or 4n plus 3. That is your rule. That's what will go here. 4n plus 3. Now I need to know what term 207 is. So I'm going to set 207 equal to 4n plus 3 and find out what n is. So in other words, what place is 207? Subtract 3 and divide by 4. What do you get? 51. So this is the 51st term. So this is going to be a 51 right there. So how do you write that in summation notation? The sum from 1 to 51 of the rule 4n plus 3. Now, if I ask you what is the sum of these numbers, the formula looks like this. N over 2 times the first term and the last term. Well, how many terms are you adding together? Well, that was the 51st term. So it's 51 over 2. The first term is 7, and the last term is 207. So if you add these up and multiply by that, that's what the sum would be. They're not asking you to do that, but you will have to do that. Okay? So let's do let's practice a couple of these. Number 3, got it. What is the summation notation for this series? So here's A. Might need to write small. What's the summation notation for A? So we're adding up the first term, so we don't know what 268 is, and I need the rule. Well, let's find the rule first. The rule would look like this. A sub n, it's the first term plus n minus 1 times d. Well, the first term is negative 5. And what are they doing to go from negative 5 to 2, from 2 to 7? What's the pattern? What's the pattern? What's the common difference? 7. So let's simplify this. A sub n is 7n minus 7, or 7n minus 12. So that's what goes here, 7n minus 12. Now, I need to know what term 268 is. So I'm going to put 268 here to figure what n value that is. So if you added 12 to 268, you get 280. 280 equals 7n, divide by 7, and n is 40. That is this top upper limit. So you're adding from the first term to the 40th term with this rule. This is your explicit formula. Yes.
So the bottom is always gonna be n equals 1?
No, no. It's not always gonna be n is 1. For example, I could give you this series right here, and I could say, Robert, add up the third term to the 50th term.
Okay, so it's
Or
the
50
term you wanna start with?
Yes, so if I don't have 1 here, that means I want you to add this one first, from here to here,
Okay.
okay? So you gotta be careful. Now, if you do see something like this, and by the way, for all of you that are taking pre-calc next year, this is the first chapter we start off with. So the better you do in this chapter, on this test right here, the better you will start off in pre-calc. This is our beginning chapter in pre-calc, is these, we review all this. The problems are the same, but they're deeper. You're gonna see more of this situation where you're gonna get a sequence and a series, and you're gonna have to add, maybe not the first term, but starting with the third or the fourth to a certain number, okay? So, in this case, how many terms are you adding together if I gave you this? If it starts with 1, it would be 51, but you're not adding 51 terms. Anyone know how to do this? It's a little trick. You subtract these two numbers and add 1 to that. You get 48 plus 1, there's 49 terms that you're adding up, okay? Let's do B. So, let's see if we can do this. We're adding up from 500 to 10, this pattern, 500 to 10. I don't know how many terms I'm adding together, I don't know what 10 is, and I do not know what the explicit formula is, so this is what I do. A sub n, it's the first term plus n minus 1 common differences. Well, what is the first term in this sequence? 500. What's the common difference?
-10.
Yeah, so simplify this for me, please. an 500 minus 10n plus 10, or 500, or I'm sorry, let's do the negative 10 first. Negative 10n plus 510. So this is what you have. Summation from 1 to, we're going to figure this out in a minute, negative 10n plus 510. Well, what is number 10? What place value is it? So you're going to put a 10 here. You're going to figure the n value. So what do you have here? Subtract 510. So you have negative 500 equals negative 10n. What's n? 50. So that's the number that goes up on top. So this answer should look like this. The sum of 1 to 50, and the formula is negative 10n plus 510. That's what that answer looks like. So now, if I asked you to find the sum of this, the formula looks like this. It's n over 2 times the first term plus the last term. Well, how many terms are you adding? 50. And the first term in this sequence was 500, and the last term was 10. So if you do that math there, that's what the sum of those numbers are. Okay? So now, here's your formula. Now the objective is, if you see an equation, and it's written in series notation, like this is series notation, can you tell me the sum? You have to be able to read this problem, it looks like Chinese writing. It's asking you to, that Greek letter means add up. Add up, that means sum. From term 1 to term 70, this is the rule. That's your rule. That's the rule. That's the pattern. Now, what's the formula? It's n over 2 times a1 plus an. How many terms are you adding? You're adding the first term, the second term, the third term, the 4th term, all the way to the 70th term. How many terms is that? It's 70 terms. Now, how do you figure out what the first term and the last, this is the first term, and that's the last term. This is the lower limit, and this is the upper limit. So the lower limit, what you're gonna do is plug 1 in here. When you let n equals 1 in here, what is the first term? 1 times 5 is 5, 5 plus 3 is 8. When you do the upper, the last term is 70, the 70th term, you're gonna plug 70 in here. What is 5 times 70 plus 3? 353. Can I get you guys to do this on your calculator? And tell me what you get. Anyone have an answer? 35, yep, 12,635. Okay, try the next one. So, we're adding up term 1 to term 40. Well, how many terms are you adding up? How many terms are you adding up? 40. So 40 over 2, what's the first term? You're gonna plug 1 in here. 3 times 1 is 3, 3 minus 8 is? Yep. And what's the 40th term? Plug 40 in here. What's 40 times 3? Minus 8. 112. 120, I'm sorry. Yeah, 120 minus 8 is 112. So now add this up, or multiply, you could divide first, and then add this. This is gonna be 107. Anyone have an answer? Anyone?
2,140.
Beautiful. Okay, now the story problem. It says, now we're gonna apply this information to these problems. A company is going to give a $10,000 bonus to any person that at the end of their first year, at the end of their first 50 weeks, if they make 10 sales in their first week, and they improve their sales by 2 each week thereafter. So they'd have to start off with 10, and every week, for the first 50 weeks, they have to increase by 2. So what would be the next, what would be week 2? How many should you have? How many sales? 12, because you're gonna add 2, then 14, then 16, so forth. It says, there's a salesperson that did qualify for this bonus. They made the minimum possible number of sales. How many sales did the salesperson make in week 50? And then in all of the 50 weeks total. So the first week they sold 10. The second week they sold 12. Then 14. Then 16. Can you tell me what's happening here? What is the rule? The rule is, it's A sub n, it's the first term plus n minus 1 times d. The first term is 10. And what are they doing? They're adding what to each week?
2.
2. That's your common difference. So, here's the rule. A sub n is 2n minus 2, so 10 plus 2n minus 2, or 2n plus 8. So that's the pattern. In week 50, how many sales did this person have? Well, you're going to do 2 times 50. What's 2 times 50? 100, 108. So in week 50, this guy sold 108, whatever it is that he's selling. They didn't tell us what it is. Now they want to know how many sales did this guy sell in all, so in other words, we're going to add 10 plus 12 plus 14 plus 16 all the way to 108. This is the 50th week. So what's the formula for the sum? It's N, how many weeks are you adding up over 2 in the first week plus the last week? Well, how many weeks did this person work? 50. 50 over 2, in the first week they sold 10, in the 50th week it was 108. So you're gonna add these two up, you get 118. 118 times 25 is the total amount that this person sold, which is 2,950. So if the question is asking you, how many sales did this person have in all 50 weeks total? 2,950. If they're asking you, how many things did they sell in week 50? It's 108. Okay, see if you can try this one. The same scenario, except for there's an alternative bonus. This guy's gonna get $5,000 if they start off with 10 sales. In every week, they add at least one to the sales. So in week 1, it's 10, what's week 2? 11, then 12, and then we need to know in week 50. So what's the pattern? A sub n, it's the first term plus n minus 1 times d. The first term is 10. What are they doing each week? They're adding 1. That's the common difference. So 10 plus n minus 1 or n plus 9. That's your formula, n plus 9. So in week 50, how many did this person sell? 59 in week 50. Well, what did this person sell in all 50 weeks, the sum of them? So it's the number of weeks you're adding up divided by 2, the first week and the last week. Well, there's 50 weeks, 50 over 2. In the first week, it was 10, and then in the 50th week, it's 59. Anybody have an answer? Is that right? Anyone else get that? 25, let me double check. 25 times 69. Yep. Okay, so this back side is your homework for tonight. This back side. Emma, can you shut off the camera?